We're live. What is this, Lady Ada?
Hey, everybody, and welcome to a wonderful Wednesday evening show and tell at 7:30 p.m. Eastern Time. And that means it's time for show and tell with me, Lady Ada, and Mr. Lady Ada, here at Data for Factory, where we do all of the engineering, designing, shipping, testing, manufacturing, packaging, etc. that we all do and love. But now we're here hanging out for the next half hour and watching the maker community show up and show us what you're making. So we're going to call
Maker community is a big deal. Today, Vans announced that they have maker shoes. They're called Makers by Vans. I'm not kidding. This is a real thing.
Oh my god. Okay.
Yeah. So now I know what type of shoes I'm getting.
Can you store components in them?
No. But
anyways,
maybe
we're gonna call on you, show off your Vans or whatever the heck you built.
Yeah.
And we out of here at 7:50. Taking off for some Adafruit folks.
Yep. All right. Now, Pedro, what you got printing this week?
Hey guys, today we put together a little camera body design for the AMG 8833 and the TFT Featherwing. That's a 2.4-inch display. And it's running off an ESP32. And this is a part of the demo sketch that comes with the Arduino library that was written by Dean. So I just want to talk a little bit about the camera body design. Somebody actually mentioned in the Thingiverse comment about that it reminded them of the Diana toy camera. And I was like, what is that? So I looked it up, and apparently it was a toy camera that came out in the 1960s. And it was like this cheap, the company that manufactured it was a plastics company. They didn't even make cameras. So it was like this novelty toy thing. But the thing that was cool about it is because it was plastic lens, it actually made like this weird, like light leaking and basically Instagram filters, like lomography is what it kind of, I guess, sprouted from. So that was my sort of design decision to make this, because I did search for, on Google Images, I search all the time, right? I searched for cute camera, and Diana camera is what came up. I had no idea it was the Diana camera. So that's where the design inspiration came from. Something I didn't even know. It was kind of like a subconscious thing. I knew I wanted it to look iconic and cute, and that was sort of the camera. So it's sort of like the Diana toy camera.
That's cool.
Yeah.
All right, well, thanks for the update.
Okay, Red, we'll be that video.
A little history lesson.
More.
Cool.
Okay, next. Erin, hello, Erin. How are you?
Good, I'm good. This week I'm working on a unicorn project. Yay! I have 3D printed a unicorn horn. Actually, it's based on a tutorial layer by layer that Noe and Pedro did a little bit ago, which is a great tutorial. And right now, what it's got some neopixels in the base that are all rainbow, and then it has this copper tape around. And I'm kind of doing it too much, but when you touch the copper tape, then the neopixels go out and the tip of the horn starts to glow, because, you know, unicorns can purify things and stuff. So that's kind of what this project does. It's capacitive touch, and it uses a Gemma M0 inside, and it has like a little charger on board. It's pretty cool. So I'm working on getting that fancy and into a tutorial, and we're going to put that up on the learning system probably later this week.
Yay! More unicorns.
Right on. All right.
More.
Next up, Blitzy. Hello, Blitzy. How are you?
Hey, how's it going?
Good.
So I've been working on, it was kind of on a whim project. I got a NeoPixel ring for a different project I had in mind, but then I realized it kind of fit over my GoPro. And I'd just done some time lapses with it. And I noticed it was kind of dark, so I thought about doing a lens light for it. So I 3D printed kind of a diffuser out of a clear PLA. And then right now I've got it running with a trinket, and it's an RGBW NeoPixel ring, so I'm controlling the amount of white with the potentiometer. So I'm like controlling the brightness, so I can get nice and bright. I just did some test footage with it, and it actually looks pretty good. It's the natural light one, so it's not looking blue or anything like that. And because I have the RGB values all at 0, then it's not getting any of those tints. But the next step's going to be adding on to the STL file so that I can have a tiny little trim pot on the top to adjust the brightness, and then have the trinket kind of sit on the side. I kind of want to have it like slotted. And then when I do time lapses, I just have the GoPro on wall power, so I'm going to have the trinket also on that too, so the USB will just come out the back. But yeah, that's what I've been working on.
Sounds great.
Cool project.
All right, thanks for the update.
Thanks.
All right.
Let's in.
More Adafruit folks before we get to everyone else. Colin, what you got going on?
Hey, y'all hear me all right?
Yeah.
Okay, good. Well, I stopped in, was it a week before last, to show off those giant mechanical keyboard switches. which are just really cool novelties, but they actually work. So why don't we actually do something with them? So got 3 of them going on here, and I'll show them to you. You can see here I made a little makeshift open beam frame for them. That's the biggest thing is you have these switches, but you don't have a big plate to put them on. And right now they work. They light up. Each one has an LED inside. I even made it sort of like a color mixer. So the corresponding color will mix on the Circuit Playground. But these actually work now as keyboard commands. So you can assign anything you want to each one. And per somebody's good idea, I have them set as Control, Alt, and Delete when you want to do a program purge.
That's right.
So that's coming on. And next up, I'm going to put them into this wooden frame I made, which is just dowels and wood glue. And quite stylish.
All right.
Very stylish.
That's my scene. I'm sticking to it.
Thank you so much, Colin. Okay. Next up, Ketney. Hello. How are you?
Hey, Kenny. Oh, we can't hear you.
You
I need to unmute.
are now live.
Now we can hear you.
Excellent. So I have done this project. It's a light box, tabletop light box for photography. And I wanted to have it be all in one. It's running off of a Raspberry Pi Zero. And we wrote a Python program that has key inputs to make the lights brighter and dimmer and change up different patterns and that sort of thing. So I wanted to hook up button shims. However, the number of inputs we have was larger than the number of buttons on one of the shims. So we wanted to stack them. However, to do that, you have to worry about I2C address conflicts. So we actually physically, there's a tiny, let's see if I can get it in there. There is a tiny yellow wire right underneath the chip. So we've physically cut the current address and then used a jumper wire to set the top board to a different address. And just today I managed to get the program itself automatically running. So next thing I need to do is get the button shim code working so that they work as inputs, and I will be able to power on the Pi and have the whole thing start up, and it will be completely self-sufficient to the Pi.
Yay!
Very cool.
Amazing.
And for the folks in Discord who probably recognize Ketney's name, thank you so much for all your work and tutorials and help with Circuit, Python, and more.
Thank you. You're very welcome. I'm loving it.
Yeah.
Yay.
All right. Next up, we are going to go to JMK. Hey, JMK, congratulations on your launch of JMK OS, by the way.
Oh, thanks. I've been messing a little with the JMK watch design, some battery movements right now that there's no wristband on. And this is just like a simple control panel app that shows off all little colors it can show. At the top, you can see welcome in all different colors. And then you can just, if you press like this button, it tells you if you press the top left button, I think it shows some sleep options like sleep settings and what to do just to wake an app once it sleeps. And then if you go to the bottom, it's just some color settings, meaning, so when you click it, it goes into a while true loop where you can then, you click a button and it'll change the font color to white, red, blue, or green. And yeah, let's see here. So yeah, I don't think it'll work just because wait, actually, I can show my screen at the code. Let's see here. I've got 3 screens going right now. I think it's that one. Okay, so here is the code. So here's it. Press buttons for color if you get lower left. While true, if it gets the button upper right, blue, lower right, green. Uh-oh, that might be the problem. Upper right, upper left. Okay, well, that's why.
We're doing.
Well, now we know. Well, that wasn't working. Okay, so now that we fixed a bug.
Yay!
Yay!
So
that's what we do.
Stop the screen share. So yeah, I've been working on. Let's turn that back on.
Okay, so what's next for your watch?
So next I'm probably going to finish some things about the color. Probably mess with some graphics, like making like a kind of more graphic game. I took some of the code from the example, which showed a little bitmap. Like it was actually I can't imagine how hard it was to make that, because it was like Flappy Bird, the whole background color, and Flappy Bird as a sprite, but it was like each pixel was defined as TS8B red, TS8B red, until you finally got all the way to the middle where you started yellow.
That's not good.
Yeah. So I cut some of that code and made it just like a flipping around Flappy Bird and some other things. And yeah, so next I'm probably going to get some graphics, get the micro SD extension so I can have multiple apps at once, and then the only script running on the main board will be a app switcher and then like app loader. And then also there is a media player function of the device, and I'm definitely going to test that out because I want to see if I can play something on that. Okay. Also, today, I think right now it's still uploading. I'm releasing a What is JMKOS video, and
oh great.
Also,
well, email me before, like you did before, and I'll post it up as an update to the JMK launch post.
Okay.
Awesome. Yeah. So yeah.
Thanks so much, JMK.
Congratulations on the release. Come back next week. We'll send you stickers and all.
Okay. Next up, Coding Pro. Coding Pro. What you got going on?
So, you know, I got a 3D printer a few weeks ago for Christmas, and before I was looking at some Legos, and I was making my own version of Legos, and they weren't really that good. They had square tops, so it didn't really fit together that well. So I took that design and I 3D printed some more real Legos.
That's cool.
They're clear.
Those are nice.
And if I can share my screen, I can show you the models. So these are the small Lego bricks. And I'm using SketchUp for this one. And the big ones are here.
Okay. Yeah, 2x4s. Classic.
Wait, did I get the right one? These ones, right?
Yeah.
Yeah. So you can make like new exotic shapes in Legos if you want. You don't have to go with the classic sizes. You can make 1x25.
Yeah, and I was thinking of making some different types of Legos, like a Lego for like more complicated Legos than ones more for experienced people in like design maybe or something.
Okay.
That's cool.
More like edges and all these different complicated designs.
Okay.
All right, well, keep up the good work and come back with your building block compatible examples. Yeah, Lego yelled us before because we put Lego compatible on a product, and they're like, you can't do that.
Yeah.
So we had to say building block compatible.
Oh yeah, it's also works with real Legos.
Yep.
Yeah.
Building block compatible.
That's fun. Like you don't have to buy Lego again. The 3D printer opens up
That's right.
a world of amazing.
Okay.
Okay.
Thanks so much. Next up, John. Hello, John. How are you? Unmute your mic and show us that glowing shirt.
There we go. Yeah. This glowing shirt is, I'm the guy with the tuba that has been up here before. And I've never been too happy with the control box that I have for that. And so I've changed things slightly. This version is actually running on a 32U4 feather blue fruit, that whole thing with everything all combined together. And the cool thing about this one, so I was just at a convention called PAX South, and so I'm using just about everything this feather can do. I wanted something fun that people could crowdsource and things like that, and in the process make a better control box for this. So I've been trying to figure out how to get screen sharing working on my Android phone. It's not working. So I'm gonna try to see if this works. Can everybody see that?
Yeah.
Okay.
Looks great.
Okay. So what ends up happening is a notification shows up. I'm broadcasting a notification to everybody there. I'll do it this way so you can actually read it. I'm broadcasting a notification or broadcasting a Eddystone URI that takes you to a website. And when you get to that website, you can actually control my shirt. You can pair with it from the website. and then you can
Camera
do
dropped
things
off
like.
for a sec, John.
Sorry. Oh.
Yeah, your camera dropped off. Now you're just a still with like these cool little.
Oh, beautiful. Let's see if it turns back on.
Well, we can just come back to you.
Somebody controlled your
let's
Wi-Fi.
I think I lost. Somebody must have hacked my Wi-Fi. That's probably it.
All right.
We'll come
So
back.
yeah, come back to me. Come back to me when I have video again.
Yeah, if you're here, you're here. If not, come back next week.
Yep.
Okay, next up, Dave. Hello, Dave. How are you?
Welcome back, Dave.
Hello, everyone. I've got a couple more dot star projects this week. Carry on from what I was doing before. So I did this one, which, let's see if we can get it to see. It's a little game with the joy wing and the dot star wing.
That's fun.
Using my library that I wrote a while ago. Oh, and I crashed.
You're doing pretty good there.
And so that's all in CircuitPython. And the next one is also CircuitPython. This is using the dot star directly without my library because it's rather demanding. There we go. So this is Phil Burgess's digital sand demo.
That's fun.
That the Rez brothers did something with last week. This is all in CircuitPython.
That's cool.
Using the dot star display.
I think that one will definitely benefit from the M4 chip.
Oh, yeah.
This stuff's hard for Python. It's like, math.
It works out with 10 grains and reasonable performance.
Yeah.
It's kind of fun.
So, yeah.
That's cool.
Yeah.
Okay.
All right.
So that's it for me.
Good work, Dave. Thank you so much.
Right. Take care.
And a reminder for everyone who wants a show and tell sticker, just email support@adafruit.com. John is back. Welcome back, John.
Okay.
Hey, okay, so I'm back. So yeah, so I think what's happening is, and I realized this while I was doing this. It's not super important, but I was had my phone connected to the same USB hub as my camera. All right, so let's try this one more time. So Chrome for Android has a fun little thing where you can actually connect to Bluetooth GATT services.
Huh.
And so I'm able to actually control this. You may not be able to see it, but I can do things. So if you remember, one of the cool things that I had was a glitter switch. And right now, if you see it, the glitter is on. And I can actually hit right here, and I just turned the glitter off over Bluetooth, local Bluetooth connection through just a HTML web page and JavaScript to my phone, from my phone. And because I was broadcasting this URL to this website to anybody who was nearby me, I kind of was able to do crowd control of my this is my I actually volunteer. So our volunteers are called enforcers, and I was able to do crowd control of the back of my shirt without needing an active internet connection. It just all worked over local Bluetooth instead.
It's like a dream of web Bluetooth. I think they've been working on this for Chrome for like years. So you're the first person to ever use it that I know of.
This is the first time I've seen it.
Yeah, I've never. It's been like an open issue forever.
The prophecy has happened.
I'm the first person I know of that's ever used it too. Because I had the Blue Fruit thing and I realized it could just do GATT services, and the Chrome thing just interacts with GATT services, it all just works out.
Cool.
It just, I have a few services that just say what pattern, whether the glitter's on or off, and what colors are on, and it'll let anybody connect and use it. And it's pretty cool. And with the BLE beacon, URI beacon, then anybody can find it. It's discoverable by anybody who has an Android device because it only works on Android. And then because it's only Chrome for Android where the Bluetooth works, then it works out.
So all the cool kids have Android phones.
Of course, drop a note to support@adafruit.com for a sticker. And if you want to do this up as a guide to pioneer teaching people this.
Yeah, this is the dream.
Yeah, email PT@Adafruit and we'll get you going with that.
Yeah, and this is going to be open source like my tuba is. So yeah,
outstanding.
Open source.
All right, thank you so much, John. Okay,
no
Carson. Hello, Carson. How are you?
Hello. So I made a couple of different things over the winter break and recently. So I made this sew some neopixels to my shoe for like a funky shoe day at school. And then when you turn it on, it just runs a normal like rainbow across the neopixels.
That's funky.
Yeah, and even though it's just an example, it's lights, so everyone thought it was cool.
That is cool.
Yeah.
Hella cool.
Then I also made this, which is a camera. So button on the top, and then it starts taking a bunch of photos, then it stitches them all together, and there's a Raspberry Pi inside. And then it takes them onto a GIF, and I have a bunch of folders that contain all the GIFs, and I can plug them in. Reader here.
Cool.
And then, boom. So if I like take a GIF right now, it takes like a couple of photos, so I know when it's done. Then here, open it up. So this yellow LED here means it's converting. And then there's a Raspberry Pi camera. There's 3 LEDs. So red when it's taking the photos, yellow when it's converting, and green when it is done and ready to take another. There's an arcade button wired up to the Raspberry Pi GPIO. There's a little shim on top of the Raspberry Pi, and a charger and a switch that just turns it on and off.
All right, nice work. These are some good projects.
Great project, and plenty of room on that cardboard box for Nessie on the show and tell sticker. So,
yeah.
So email us. I sense a trend. There's all these cardboard projects. Nintendo announced one today.
Well, everyone's got cardboard around. All right, nice work, Carson.
Good work.
Thank you.
Next up, Adam. Hello.
Hello. Really good timing. Actually, just got this thing dialed in after having it shut down this morning. So good job on that one.
Yay.
This week's been kind of interesting. I've done some pretty cool stuff with it. I actually got high resolution capture working-ish, and I'll show you why it's ish. So go ahead and share screens real quick. And you can see
today that you can use. I think it would be good for SEM.
Oh yeah, I know. I saw the post on it this morning. It looks like it's got like 3 or 4 metal oxide sensors built into it.
Yeah.
Yeah, it's gonna be exciting. But so this is a really cool sample. One of my friends gave me. They work at the Seattle Aquarium and got some really cool seaweed samples and dried them out. And I got a sputter coder recently from work, and now I can image these really, really cool biological features. So this is actually at like 1800 and 3600 meg right here. And so we're getting some really clear images, except for this really weird noise we're seeing. And you can see we've got both these jagged edges and this horizontal banding. And I had seen this effect on my monitor, on the monitor at high magnification, but I'd have to be at like 60 or 80,000 times magnification. But when I do a really slow scan rate to generate these high resolution images like this with my camera pointing at the screen, I start to get this really weird noise. So that sent me down the path of trying to figure out where is said really weird noise coming from. So I had to kind of build some custom hardware. I've got it now, so I can actually operate modules from the control rack outside. I harvested some old connectors, got some like 14 conductor cable, and so built basically a riser cable so I can get these cards outside of here and probe it. Turns out that wasn't necessary because I have a truly massive ground loop problem right now, which is kind of horrible. What's supposed to be 0 volts is actually connected to earth ground, which it's definitely not supposed to be. In these really high precision supplies, you actually have your 0 floating or conductively or AC coupled to ground. You don't want it connected to ground because then you get a bunch of ground noise. So I've got a giant ground loop coming from my main power supply through the frame, through the column, and back to the supply again. And so that's actually inducing a lot of noise in my scan coils, which is making it so that the beam is wobbling around in the chamber, even though I've got a good beam on my CRT. And so that's where that really high mag noise is. So beyond that, though, we can actually still do some interesting stuff with it as long as you're not trying to do high resolution capture. Under it right now, I have got the nth light LED strips. And these things are actually really, truly mind-blowing. As you can see on the monitor, I've got the instrument running at... Oh, let me get that centered real quick. I've got the instrument running at 30,000 or 3,000 times magnification, so just about twice of what any sort of optical microscope can see. And we can actually start to see the features of the LED. Now, the actual LED emitters, they take a big wafer, they make a big wafer of LED, and they cut it up into millions and millions and millions of little pieces, and then suspend it in an ink or in a solvent or a pigment that they can then print out. And these LEDs now are these little, literally blood cell sized things that they can then print out, and we can see that textured pattern. And I can zoom in a bit more too, and then refocus because it's still in warm up, so everything's drifting around a bit. And refocus, and we can actually see it's this really interesting manufacturing process where they're printing all these different layers. And then if you zoom out again,
yeah, it does look like some blood cells of some light emitting creature.
Yeah, that's a really good metaphor for this. You can actually see they've got to get to this point. I had to take off a bunch of layers, so I've de-layered this thing, and then I would wipe away the silver ink with acetone, and then that would leave me with this layer. We can actually see here there's multiple layers of polycarbonate, and then in the very bottom, and I want to move to this because this is actually really interesting how they did this. They basically suspended microscopic wires to create a really flexible, transparent layer that the LEDs actually shine through. And the reason they couldn't use something like you normally use in a, I guess I'm not quite in focus. Let's see, gamma off, brightness up. This is a whole ordeal right now. The instrument's still in warm-up, so everything's really shifting around. Okay, there we go. So you can actually see these little wires here. And the reason you use these wires is that it's way more flexible than something like an indium tin oxide coating that you'd usually use in a transparent device. And these wires will flex at the display and allow it to still conduct and transmit light, even though they're using a solid conductor that's just microscopic. I mean, this thing is many, many times smaller or in diameter than a human blood cell. And I'm at just about 10,000 times magnification right now just to start to see these details. So.
This is super cool. Thank you for showing this, because it's neat because we have the product in the store. You have one of them, you're able to then show. It'd be neat to look at. I'm sure if it's not patent pending, there's probably some documentation on the process. It'd be neat to then look at the process that they describe and then the results through
That's actually how I've been able to figure a lot of this out. Is all of this is well, I will say Nth really loves their patents, and patents, they document the manufacturing process because that's how they have to do to get a patent for something like this. Because really, they're patenting the process in this case. So there's a lot of really good information in there on how they do a lot of this stuff. So it's literally a roll-to-roll printing technique, and they can spit out like 20 feet per minute of this stuff. It's kind of insane. Cool.
All right. Well, thank you so much, Adam. That was enlightening. Haha.
Yeah.
You're on week. Okay. And then we have one. GB. How's it going? Hey. We got one more person. If you can keep it to a minute-ish, we can fix you in.
All right, so I've been working on so much stuff this week. So with the computer project, I put that on hold because I have a friend actually working on building a compiler for me, because I got bored of coding in machine code. But after that, I started working on this, which is an LED driver.
Nice.
Oh, wow.
It's a screen driver for 3 LEDs. It uses a Texas Instruments shift register of some sorts, a LED 7-segment decoder, and 2 hex inverters, because these are a common cathode and it's a common anode thing. Then I just have a little script for an Arduino running. I can't boot it up right now because you have no idea how unstable this is. Because it's a work in progress, but it's incredibly unstable. For some reason, the screen, the way it works is it shifts 1 bit in between the screen to activate them. But sometimes it'll have 2 bits, or 3, or none. So sometimes it'll just totally bug out and the screen just displays garbage or nothing. So I don't know how to fix that just yet. It's probably something to do with static electricity in the air or some weird connectivity problem. But yeah, besides that, I built a high voltage thing with a disposable camera, and I put it to 9 volts, and I can use it as a small spot welder.
Oh, that's cool.
That's good.
Do you want to come back next week and show some of these?
Yeah, sure. And there's also one more thing. So I bought something that cost quite a lot of money, and hopefully it's going to arrive before next week, and I'm really excited to show it off. And it ends with 64. Guess what it is?
Okay.
Ooh, this is a puzzle. All right, 64. Okay, all right. Might be like a Nintendo 64 or something.
That's too easy.
No,
I already own an N64. It's right here. So.
All right, so that was not a bad guess. All right, well, thank you, GB. GB. Email support@adafruit.com for a sticker, and come back and show some of these things.
Yeah.
All right.
Really did or not.
Yeah.
All right. Thanks,
All right.
everybody.
Thank you so much, Katney,
John,
JMK, GB, Dave, Colin, Coding Pro, Carson,
Carson's camera,
and Adam.
And Adam.
We're here every single week, 7:30 p.m. Eastern Time. Thank you for making this the best half an hour of our lives every single week. We'll see everyone on Ask an Engineer in a few minutes. Have a good week.
Hey, everybody.